An amazing high-tech tool that you can add to your aviation toolbox is the laser. It is inexpensive and can be found at your local building supply or hardware store. What is it good for? There will be occasions when constructing your aircraft that you will be challenged to keep your assemblies straight or in line with one another. For example, a wing that needs to be constructed flat along its long distance and have no twist when measured from one end to another. How do you check that structures are indeed straight and without twist? This is where our handy laser makes that task easy. There are 3 types of laser beams of interest to us. One that produces a single point, one that produces a horizontal line, and one that produces a vertical line. Each can be useful in various building scenarios. Here is an inexpensive laser. It's about $15, and it sends a single beam of light, just a point at the other end. This model has a couple of screw clamps. The idea is that you can attach it to a level if you so desire. That's optional. Let's take a look at what we can do with a laser that sends just a single point of light. We have the laser sitting on one of the corners of our workbench. Now, many builders wonder just how flat their workbench really is, because we know a flat surface will contribute to the quality construction of the components that are built on top of it. Well, one thing we can do is take a look at a ruler and measure the distance between the surface and the intersection of the beam. And we can move this all around the table and compare that measurement and find out if there's any high or low points in the table. And this is very easy to do. We can reverse the laser, put it at the other corner, and check any spot on the table and see just how flat it is. This can be done, of course, with the aircraft components also, wings or spars or other long objects. Wherever we would love to cast a very straight line and check for any variations or irregularities. My goal is not to recommend or even review laser models, but I wanted to show one as an example. This one is from Harbor Freight. It comes with a tripod. It costs about $50 or so, and it produces both a vertical and horizontal laser beam line. This model from Harbor Freight has 2 buttons on it. When I push one of the buttons, it gives us a horizontal line. And I can get it to shake a little bit. That's because the laser will self-level, there we go, get it to shake, so that you get a true level horizontal line. Now there's another button on it, and that gives us a vertical line, which also self-levels. You can also press both buttons and get the horizontal and vertical lines. Our challenge with this project was to be able to attach the rear fuselage with the forward cabin in such a way that our tail post at the very end was perfectly centered from left to right with the cabin. So before drilling the holes and attaching these 2 pieces together, we wanted our alignment to be as close to perfect as possible before drilling the holes and making it permanent. In order to align the rear fuselage, I needed to shoot a line down the very center of the entire structure. So my first step was to make a mark in the center from left to right. We have one here at the very front, and then we have another line at the next station, and then coming to the rear of the forward fuselage, we have a mark at the very center here. And then, of course, our goal is to have the very back end, or the tail post, be perfectly in line with the center of these forward structures. So let's cast a line down the very center, not with a string, but with a beam of light. Our laser, and that's on a tripod right in front, casting the beam right down the center. Now in this example, we have the vertical line energized on the laser, and we'll try and see that at the very front of the fuselage we have a line, and then going back, so we have it lined up with that, and we will continue to go to the rear, and then going all the way back, we have aimed for the tail post. So way back here, we see that the laser shows us that we have our fuselage angled from left to right just correctly because we are striking the tail post. Here's another example of using the laser. It's kind of hard to see possibly, but this is a nose fork and the strut that attaches to it for the front of a plane, and I need to locate a hole perfectly in the center based on the middle of the fork and going straight up the shaft. What a great way, as long as I mark a reference line, probably can't see it, but when I aim this laser and I make the red line go all the way up to the top of the strut in the center. So anytime you need to locate an exact center on something that really doesn't lend itself to striking a string or drawing a line, this will give you a super accurate temporary line. In conclusion, whenever a straight line or string could be used to help you line things up or confirm how straight an edge or boundary really is, an inexpensive laser may be able to help you quickly accomplish this. A great addition for every builder's toolbox.